Welcome to Gen.Struct.2 and Lat.Forces, Lesson 4 quiz. Question number 2. It says, in a tall building, which of the following systems is usually most effective in resisting earthquakes? And just off the top of my head, I remember that moment resisting frames are the best. They are, I guess, the most flexible is what I would call them. So let's go ahead and take a look at these potential answers, and we'll cross off the ones we know are incorrect, and then we will say why they are incorrect. So right off the bat, we see the shear walls at the perimeter. So I know that's incorrect. And a shear wall is that diaphragm, or it's a wall of some sort that resists that lateral movement back and forth. And so if you have this frame, let's say, and then you have a shear wall, let's say it could be concrete like that. And when something moves right here, it's going to try to transfer that load, and it's going to end up transferring that load up here, and then you'll resist it at some point. So you'll see this forces all across here, and it's kind of like a large, very, very deep beam. So that, if you think about it, I mean, if you went in, so it might be easier to, well, actually, a concrete wall would be fine, where let's say it's rigidly connected over here, and it's rigidly connected over here to whatever framing system you have. So when that moves, it's going to be rather rigid, and therefore it's not going to be able to flex and move. I like to think about earthquakes like trees. Why do trees stand up so long? And it's not because that they are really, really strong. It's more because they're flexible and they're able to withstand the sway back and forth and the flexibility of those trees. You see the wind blow. So these shear walls make this building, if you had a bunch of shear walls, it would make the building very rigid, and therefore it's not the best for earthquakes. So this is incorrect. I'm trying not to be too specific here. All right, moment resisting. I said at the beginning that is going to be one of the better systems. So let's go ahead and skip that. It says moment resisting frames at the perimeter. That sounds pretty good. Moment resisting frames. So once again, if you're wondering what a moment resisting frame looks like, go ahead and take a look. But it's not going to have this diaphragm. It's going to have just the frame, and then this right here and this right here is going to be a moment resisting frame. This will be a beam system, and that will be another beam or a column, a beam, moment resisting frame, and another column. So this is a shear wall, and it once again is a lot more rigid. I think this sounds like the best answer. It says at the perimeter down here. It looks like it has another moment resisting frame. It says set back from the perimeter and rigidly anchored to the perimeter elements. And once again, the more I hear this rigidity, the more I think, oh, well, we want it to move a little bit. We want it to be able to be, not really, well, if you want to say ductile, I don't really think that. I just want to say more flexible. So, once again, I would say that this B is a better answer than D. So let's go ahead and cross it out. Now let's go to C. Braced frames at the perimeter. And here is how I would describe a brace frame. First of all, that's not the correct answer. Brace frame looks something like this, where you have these, you can have one right here, or you can have X bracing. And the way I like to think about it is this is more rigid than this moment resisting frame. This moment resisting frame, it wants to move. It will move better like this. It will move like that, and maybe the top rotates a little bit. This right here, if you put a force on it, see right here, it moved. This giant beam, or not giant beam, but this column, sways a little bit. It rotates. This entire corner here will rotate like this. Obviously, that's overstated. But if you think about this corner, it will not rotate like that. If it has to move, this, if it wants to move and look like that, this, remember right here, needs to elongate to that, and that takes a lot more force. So this system this brace system, brace frame is going to be a lot more rigid. I hope that helps. Once again, your answer for question number 2 is B, and I will see you on question number 3.